Okay, so 9, 25, 20. This is day 2, inverse trig. So with inverse trig, we are trying to find angle measure. Inverse trig finds angle measure. So first, to talk a little bit about some domain and range. So let's say I have domain here, range here. We're going to start with y equals inverse sine of x, or that's the same as y equals arc sine of x. Arc sine, inverse sine mean the same thing. So the domain of an inverse sine is between 1 and 1. The range, meaning the angle measure you're going to give, is between negative pi over 2 and positive pi over 2. For inverse cos, or again, that's the same as arc cos of x, domain, again, is going to be between negative 1 and 1. And what's different here is the range will be between 0 and pi. With inverse tan, or that's the same as arc tan of x, x can be anything negative infinity to positive infinity. Y will be between negative pi over 2 and positive pi over 2. Not counting pi over 2 or negative pi over 2, because remember, tan is undefined at the over 2's. Cotan, which is the reciprocal of tan, it could be cotan to the negative 1 of x, or that's the same as arc cotan of x. That is also between negative infinity, positive infinity. The y's, though, will be between 0 and pi, counting 0, not counting pi. Inverse sec x, or of course, that's the same as arc sec of x. Absolute value of x, they say, is greater than or equal to 1. This will be between 0 and pi. And then inverse cosec x, or again, that's arc cosec x. Domain is the same as the last one. Range goes from negative pi over 2 to positive pi over 2. And they say, comma, y cannot equal 0. That is just, showing places where it is undefined. Oops. Okay. So one thing you might have noticed, there were 3 places where we were basically from 0 to pi, and there were 3 places where we were from negative pi over 2 to positive pi over 2. So when I'm doing inverse trig, I like to come up with kind of a chart. For inverse sine, inverse tan, and sine's reciprocal, which is inverse cosec. Those, my answer is always going to be somewhere between negative pi over 2 and positive pi over 2. If I'm right on the circle, this is 0, negative 1. This is where 1, 0 is. This is 0, 1. If I'm in the chart or that's in the quadrants, quadrant 1 is your pi over 6, your pi over 4, your pi over 3. Here's your negative pi over 6, negative pi over 4, negative pi over 3. So the way inverse sine, tan, and cosec get restricted, the answer is somewhere from negative pi over 2 to positive pi over 2. And again, it's because of the way they restrict the domain of the sine curve to then do inverse sine. They want there to only be one answer. Now, for if it's, oh, I don't know what just happened there. All right, this is again for inverse sine, inverse tan, and inverse cosec. So sine, it's reciprocal, and then tan. Now, if you're doing inverse cos, cos is reciprocal, which is sec, or the oddball, which is inverse cotan. So tan and cotan are not with each other. Then you're going to give me an answer that's between 0 and pi. So 1, 0, 0, 1, negative 1, 0. So if these were the values, you'd give me 0 or pi over 2 or pi. Or if you're talking about an angle in one of the quadrants, that's your pi over 6, pi over 4, pi over 3. If we think of our second quadrant angles, right, this is where we'll think like, let's say 6 pi over 6 is on the line, so 5 pi over 6 is in quadrant 2. If 4 pi over 4 is on the line, then 3 pi over 4 is in quadrant 2. And if 3 pi over 3 is on the line, 2 pi over 3 is in quadrant 2. So what we'll do is basically if I'm saying what is inverse tan of 1? So I'm saying, okay, where is tan 1? Well, that's where we have to think of our, chart from yesterday. And I'm just going to fill in sine, cos, tan. Okay, so where is tan 1? Tan is 1 at a pi over 4. So the reference angle is pi over 4. Since it's positive, that means we're in quadrant 1. So anytime inverse tan is positive, any inverse trig is positive, you're in quadrant 1. So you're just going to give me the quadrant 1 angle, which is either your pi over 6, pi over 4, pi over 3. We'd really be looking here, this graph because it's inverse tan. But tan is 1 at pi over 4. So if it's positive, it's a no-brainer. It's the quadrant 1 angle, which is the pi over 6, pi over 4, pi over 3. Unless it happens to be, one of the quadrantal angles, which means it wouldn't be in the chart here. Let's say, though, what if I had the same problem, but it was inverse tan of negative 1? Well, still, where is tan 1? The reference angle is pi over 4. But since this is negative, that tells me I'm in quadrant 4. How do I know I'm in quadrant 4? Well, if we go back up here, inverse tan. So if you think about it, tan is normally negative in 2 places, right? Quadrant 2, quadrant 4. But for inverse trig, they restrict it so there's only one answer. So with inverse tan, you're only looking at quadrant 4. You are never looking at quadrant 2. You're only looking at quadrants 1 or 4. So there's one place it's positive, there's one place it's negative. So this would then be negative pi over 4, right? To get into quadrant 4, you'd have to go clockwise 45 degrees. You'd have to go into quadrant 4, 45 degrees. Okay, so what if they had inverse sine of 1? Well, if I look at my chart, where is sine 1? Sine is never 1 in the chart. So now I got to go to my unit circle. Again, I'm only looking at this first graph here where I'm looking for inverse sine. Where is sine 1? Well, sine is the y coordinate. So sine is 1 right there at pi over 2. If I said, where is inverse sine negative 1? Where is sine negative 1? Well, that's at negative pi over 2, right up here. So right in there is sine negative 1. If I said inverse sine of 0, where is sine 0? Again, sine is the y coordinate. So sine is 0 right up here at 0 radians. Okay, what if we do inverse sine of 1/2? Where is sine 1/2? So I look at my chart. Where is sine 1/2? Sine is 1/2 at pi over 6. So if it's positive, that's just the positive. We're in quadrant 1. So we know we're in quadrant 1, so that's just pi over 6. But if I said, what's inverse sine of negative 1/2? Well, sine is 1/2 at pi over 6. So the reference angle is pi over 6. But the negative tells me we're in quadrant 4. So with inverse trig, the way I give the quadrant 4 angle is I just say negative pi over 6. So with inverse sine, inverse tan, it's kind of a no-brainer. If the value is positive, it's the positive angle. If the value is negative, it's the negative angle. Where it gets more complicated, if it's inverse cos. Now, inverse cos of 1/2 means where is cos 1/2? Cos is 1/2 at pi over 3. Since it's positive, we are in quadrant 1, right? So for inverse cos, we only look at quadrant 1 or we look at quadrant 2. Cos is positive in quadrant 1. It's negative in quadrant 2. So I'm giving the quadrant 1 angle, which is a pi over 3. If I said, what's inverse cos of negative 1/2? I still look at where's cos 1/2. That's pi over 3. Since this is negative, I'm in quadrant 2. Because again, for inverse cos, I only look, so here's inverse cos. I'm looking either at quadrant 1 or quadrant 2, or I could be somewhere on the unit circle. But this is a value in the chart. I would say I would have to give the over 3 in quadrant 2, which is 2 pi over 3. So I give the over 3 reference angle in quadrant 2, so 2 pi over 3. If I want inverse cos of negative radical 2 over 2, where is cos? Radical 2 over 2. The reference angle is going to be a pi over 4. However, since this is negative, that means we're in quadrant 2. So I give the over 4 reference angle in quadrant 2. So if you go back, the over 4 reference angle in quadrant 2 is 3 pi over 4. All right. What about if it's inverse cos of 1? Where is cos 1? Well, if I go back to my chart, cos isn't 1 in the chart. So now I have to go to the diagram here. Where is cos 1? Well, cos is the x coordinate. So cos is 1 at 0 radians. Cos is 0 at pi over 2. Cos is negative 1 at pi. So cos is 1 at 0 radians. Where is cos negative 1? That's, as we said, at pi. And where is cos? So inverse cos of 0. Where is cos 0? At what angle? Pi over 2. If we have something like cotan of inverse sine of negative a half. Okay, now we have, we're kind of mixing in yesterday and today. So inverse sine of a half. That means where is sine a half? Sine is a half at pi over 6. Negative tells me I'm in quadrant 4. So that's negative pi over 6. And that's again because when you're doing inverse sine, that's this first diagram here. You're looking here. If it's negative, you're in quadrant 4. So you're giving the quadrant 4 angle. If it's positive, you're always giving the quadrant 1. Cotan of negative pi over 6. So now this is going back to yesterday. This is a direct, what's cotan of an over 6? Well, if I look at my chart, I didn't do cotan, but I didn't do the chart for cotan. But if you look, remember cotan, if I fill it in now, cotan was just the reverse of tan. So cotan of an over 6 is radical 3. And negative pi over 6, that's, remember, clockwise pi over 6. So you're in quadrant 4. Cotan is negative in quadrant 4. And we said cotan of an over 6 was radical 3. Okay. Arc sec of negative radical 2. Arc sec, remember, is the same as inverse sec. So this is saying where is sec negative radical 2? Well, sec is radical 2. Again, I didn't put my chart, the full chart down, but sec is radical 2 at pi over 4. But then for sec, we're over here where we were for cos. If sec is negative, we're giving this over 4, 3 pi over 4. We're giving the quadrant 2 angle. So this is 3 pi over 4. So reference angle, pi over 4. The negative, though, tells me quadrant 2 because it's inverse sec, or that's arc sec. Let's say inverse cotan of negative radical 3 over 3. Where is cotan radical 3 over 3? Reference angle is pi over 3. Negative. Inverse cotan is negative in quadrant 2. So we'd be giving 2 pi over 3. arc cosec of -2. Where is cosec 2? Reference angle would be a pi over 6. Negative means we're in quadrant 4. Arc cosec follows arc sine and arc tan, where you look at quadrants 1 and 4. So this is just negative pi over 6. Two more. If we've got sine of inverse sine of 0.735, as long as this falls within the domain for inverse sine, which it does, then these two just cancel. Sine and inverse sine are reciprocals of each other. So you get 0.735. And last one, if we've got sine of inverse cos of 3/5. Okay, so now this looks weird because we don't know what cos of what angle is 3/5. I don't know. But what I can do is I can draw a triangle, and I can have some theta, and I'm going to make the cos of that theta, which is adjacent over hypotenuse. I'm going to make the cos of that angle 3/5. So cos is adjacent over hypotenuse. So now I want to know what's the sine of that angle, that theta. Sine is opposite over hypotenuse. So I have to find the opposite side. Well, this is a right triangle, so we would do our a squared plus b squared equals c squared. Or if you know your Pythagorean triples, then you already know that that's going to be 4. So now sine is opposite over hypotenuse, so my answer would be 4/5. All right, that's it for the day 2 inverse trig review.